All right. Examples with using the unit circle to figure out the angles, and specifically the angles between 0 and 360 degrees. And make sure that you are clear that with the round bracket, 360 is not one of the possible answers. With the square bracket, 0 is one of the possible answers, and that allows for every point around the circle to be representative of one particular angle stop as we go around the circle one time. I'm going to erase that. And so here we go. Just a quick review of what we did yesterday. Okay. A quick review of what we did yesterday. Sine represents the y coordinates. And if my y coordinate is negative root 2 over 2, that's down the y-axis. You have negative 1, negative 2, negative 3. And by those, I'm meaning negative root 1 over 2, negative root 2 over 2, negative root 3 over 2. And that gets us to these centers of quadrants 3 and 4. And so if you add 45 degrees to 180, you get 225. If you add 45 degrees to 270, you get 315. And those are the only two angles for which the sine is equal to negative root 2 over 2 if you are just looking between 0 and 360. Now, the reciprocal of sine is cosecant. When you run into finding angles for cosecant, you can just change that equation into being an equation for sine, and then you just have to know how to work things for sine. You don't have to learn how to use the unit circle for cosecant. If you keep in mind that cosecant, CSC, cosecant is equal to 1 over sine theta, then what you can do quickly is you can say reciprocal of cosecant and reciprocal of the number. And when you reciprocate a number that is a nice integer like negative 2, negative 2 is the same thing as negative 2 over 1. And then when you reciprocate, you're just flipping the numerator denominator, swapping places. We keep the negative sign. And then for negative 1/2, that is the first y coordinate down. And when you're using sine, you want to draw horizontal lines. And now you're looking at 30 degrees beyond 180 and 30 degrees before 360. And you get your two answers. So that's working with sine and its reciprocal function. Then we had just started to work on cosine, and we were running out of time. With cosine, we want to be drawing vertical lines. And keep in mind that x and cosine are the same thing when we are in a unit circle. If cosine is equal to negative 1/2, then I'm looking at my first special x coordinate to the left. And that leads me to two spots on the unit circle. I want to make sure you're clear that when I get these two spots on the unit circle, that just is telling me where the terminal angles are for one of the thetas and then terminal side for that angle. And then these angles are 30 degrees beyond 90 and 30 degrees before 270. And what would those two angles be? Oh, did I see a... No, never mind. I thought I saw a doggy. Okay. That gives us... What angle is this one right here? $120. And what angle is this one right here? $240. And those are my two answers. Okay, now the next one is a little bit tricky. It's meant to be a little bit tricky. Secant has a reciprocal of cosine. What's the reciprocal of 1/2? Either you can look at this as reciprocal and reciprocal, and you're getting cosine theta being equal to 2, or you can take your secant theta and you can replace it with 1 over cosine theta and solve that equation. And you should get with that equation also cosine theta equals 2. So there are a couple different ways to come up with it. Now, cosine is an x-coordinate. And I want you to keep in mind with our x-coordinates that right here I have positive 1/2, positive root 2 over 2, positive root 3 over 2, positive 1, positive 2 on the x-axis. If I extend the x-axis out further, positive 2 is like about here. If I draw a vertical line at x equals 2, does it intersect the unit circle? What does that tell you about the answer to what are the angles where the secant of theta equals 1/2? We are getting no solution. Correct? Does everyone see that? If it doesn't intersect the actual circle itself, we will get no solution. And I want to point out to you that that can happen if you're drawing vertical lines with cosine or secant, or if you're drawing horizontal lines with sine or cosecant. There are answers of no solution for these 4 trig functions that you can get. However, when it comes to tangent, and I've been telling you with tangent that whatever tangent is equal to, you want to draw a line through the origin that has that number as its slope. Any line that you draw through the origin is going to intersect the unit circle in 2 places. You will always have an answer to tangent and to cotangent. They will always have answers. But I'm going to say again, when it comes to sine and cosine, as well as the reciprocal functions of those two, it is possible to get no solution. So now I want to remind you of what we had been looking at with slope. Where did I have that? Here we go. You know, let me go over slope again with tangent. If I draw a line through the origin that has a slope of 1, so I'm going to erase some of this. If I draw a line that has a slope of 1, that's going to show me which angles give me a value of tangent being equal to 1. And that gives me the angles 45 degrees and then 180 plus 45, 225 degrees. There are only certain answers to tangent that you're going to be expected to deal with when you don't have a calculator. That's one of them, tangent being equal to positive 1. Another one is tangent being equal to negative 1. If I draw a line through the origin with a slope of negative 1, it will intersect the unit circle at 2 places. For those angles, those are the angles where tangent is actually equal to negative 1. And then I can find those angles if I start at 90 degrees and add 45. And I could go 360 minus 45, or I could do 270 plus 45, either or. This one right here is 135, and this one is 315. And then also if I draw a slope with 0 slope through that origin, I know that tangent theta is equal to 0 at angles 0 and 180. And I want to pause again for a moment and have you just look at how many of the special angles, the unit circle angles, that gives us. We also can see that you could be asked, where is tangent undefined? And we're going to start with, where is slope undefined? If I draw a line through the origin with an undefined slope, that's going to be a vertical line. Those angles are 90 degrees and 270 degrees. Those are the two angles at which tangent is undefined. Now just look at just these. See that those aren't too difficult to remember. That's 4 different lines right there, and it takes care of 8 angles around the unit circle. The only angles that are unaccounted for with just this much would be this pair of angles who have opposite sides over there, and this pair of angles who have opposite sides over here. So if you focus on just these numbers alone so far, you have the majority of the answers for tangent that you're expected to work with. Now, I want to bring in cotangent at this point. And cotangent is tangent's reciprocal. When I'm at this point on the unit circle, I have x coordinate 1, y coordinate 0. The slope, the y over the x, is 0. However, at that angle, at 0 degrees, cotangent is just tangent's reciprocal. If I'm working with specifically 0 degrees, then I'm actually looking at x divided by y. If I'm dividing by 0, I am undefined. So where cotangent is undefined, where tangent is 0. And then vice versa, where tangent is undefined, cotangent is equal to 0. And that's 90 degrees and 270 degrees. And let me point out also, the xy coordinate here is x coordinate 0, y coordinate 1. When I'm working with tangent, tangent is y divided by x. But when I'm working with cotangent, it is x divided by y. So when I am at 90 degrees, my tangent is equal to 1 divided by 0. Dividing by 0 is undefined. My cotangent is 0 divided by 1, which is equal to 0. So just stop and let that in for a little bit. When you have a vertical line, the slope is undefined. That means tangent is undefined. When you have a horizontal line, the slope is 0. You have the tangent being 0. Cotangent reverses that. Where you have a 0 slope, cotangent is undefined. Where you have an undefined slope, cotangent is 0. So let that process, and then I'm going to erase those lines and get them out of the way. And I want to focus on these two lines. One is 1 over 1. What is the reciprocal of 1 over 1?
1 over 1.
Still 1 over 1. So it's valuable to realize that at your 45-degree angle, which has 225 on the opposite side of the unit circle, tangent and cotangent are both equal to +1. That is a place where your x and your y coordinates are identical. Right here, they're both positive √2/2. Down here, they are both negative √2/2. So whether you do tangent, which is y divided by x, or you do cotangent, which is x divided by y, you're getting 1. So tell me what you're getting when the slope is -1. What do you think the cotangent is at 135 and 315 degrees? At 135, your x-coordinate is negative √2/2. Your y-coordinate is positive √2/2. At 315 degrees, your x-coordinate is positive √2/2. Your y-coordinate is negative √2/2. So whether you have y divided by x or x divided by y, you're going to get -1. So just take a moment to soak this in. If you are at a 45-degree angle, whether you have a negative slope or a positive slope, those are the places where both tangent and cotangent are the same exact number. And if you're on a positive slope, they're both 1. If you're on a negative slope, they're both -1. Being aware of this will save you a lot of time. We still have a lot of trig coming up. And one of the things we're going to be doing is looking at the actual graphs of sine, cosine, tangent, cotangent, secant, cosecant. We're going to look at all of their graphs. If you are aware of certain numbers, it's going to make the graphs easier to remember. So take a good look at this, and I'm going to keep repeating myself with these things to help them sink in a little bit more. But realize that at this point, you now have what tangent and cotangent are at several angles. So I want to come over here to where I had written out some of the tangent values. And I want to put next to it cotangent values. When I'm looking at 0 degrees or 180 degrees, tangent is showing a value of 0. Cotangent is undefined at 0 degrees and 180 degrees. And where tangent is undefined, that's where cotangent is equal to 0. At 90 degrees and 270 degrees. Where tangent is 1, cotangent is also equal to 1. 45 degrees and 225. Where tangent is -1, cotangent is also -1 at 135 degrees and 315 degrees. This is actually a lot of information. And I do want to keep talking through these. But I want you to see that at this point, there are actually only 2 numbers that matter. So right now I'm drawing two lines. Both of them have the same steepness. Just one of them has a positive slope, one of them has a negative slope. This positive slope takes us to the angle 30 degrees and 180 plus 30 degrees, 210 degrees. If you look at the x and the y coordinates at just one of these two angles. So for this one, the x-coordinate is the third one out, √3/2. The y-coordinate is the first one up, 1/2. And when I'm dealing with tangent, tangent is the sine, which is the y value, divided by the cosine, which is the x value. And I can write that as 1 divided by √3. That's also the number √3 divided by 3. What I want you to focus on is whether you see the number in this form or this form. Do you see that that is a number that is smaller than 1? When you have a slope that is positive and it is less than 1, and you are dealing with a unit circle, this is the only line that you can draw in the unit circle that goes through the origin that has a slope less than 1 that is positive. The tangent of the one that is less steep has a slope less than 1, and it is equal to 1 divided by √3. Where I have the negative slope, that's where tangent is equal to negative 1/√3. And if you remember that tangent represents slope, then when you're looking at the positive and negative slopes that have the same steepness, it's easier to remember that they are both a 1/√3, but one's positive, one's negative. I'm going to erase these. And then I'm going to present to you the steeper ones. Look at both of these lines, they have the same steepness. For this point, its x-coordinate is 1/2. Its y-coordinate is √3/2. Tangent is equal to the y-coordinate over the x-coordinate, which is also the sine over the cosine. That means we have the square root of 3/2 divided by 1/2. And what does that reduce to? That becomes just the square root of 3. Is the square root of 3 bigger than 1? A slope of 1 is at a 45-degree angle. So that yellow line is a slope of 1. If a line is drawn steeper, and they're both positive slopes, then that slope has to be bigger. That slope is root 3. And what I want you to really do is compare now the slopes. And I'm putting M for slope. I have a slope of root 3 when I'm at a 60-degree angle. I have a slope of 1 over root 3 when I'm at the 30-degree angle. So really, the two slope numbers, the only slopes that aren't plus or minus 1 or 0 or undefined, the only two slopes that are not simpler numbers are root 3 and 1 divided by root 3. And that's really not too bad to have to add those into your memory. Your root 3 slope that is positive, and I'm going to erase a little bit out of the way. So the positive root 3 slope happens at 60 degrees, and then this angle is 30 degrees before hitting 270, so 240 degrees. Those are the two angles where my tangent's value is positive root 3. Right here. Then I have a negative slope that is also root 3, but it's negative. When my angles are 90 degrees plus 30 degrees takes me to 120 degrees. And then 270 plus 30 takes me to 300 degrees. So tangent theta is equal to negative root 3 when my angles are 120 degrees and 300 degrees. I'm going to put that in the same color. So here's what I want you to see. I want you to see that you have less steep slopes are when tangent is equal to 1 over root 3 or negative 1 over root 3. Those less steep slopes, by less steep I mean less steep than a 1 slope. When you are less steep than a 1 slope, you are dealing with either a positive 1 over root 3 slope or a negative 1 over root 3 slope. And that takes you to particular angles. If you're dealing with a slope that is steeper than a 45-degree angle, if you are steeper, you're having a slope that is either root 3 or negative root 3, and that also takes you to particular angles. Now, can you reciprocate that and look at the cotangents? These are the angles where cotangent is equal to the reciprocal of 1 over root 3. And the reciprocal of root 3 is going to be 1 over root 3. Now, when you look at all of them written down, it looks like too much. But I'm going to come back over here and talk real quick through what your slopes are again, if my pen will choose to work. Or if my touch screen chooses to work. And I think my touch screen just stopped working again. So I'm going to try to summarize without it. So we've got a slope of 1, or sorry, I'm saying the wrong thing with, you're not going to cooperate. There we go. Here is a slope of 0. That is where tangent theta is equal to 0. That is where cotangent is undefined. Undefined slope. This is where tangent is undefined, but cotangent is 0. And then I have a slope of 1. If I can get a slope of 1 going. Trying to get a slope of 1. There we go. Slope of 1. That is where, these are the angles where tangent and cotangent are both positive 1. A slope of negative 1. If I can get a little bit of cooperation. A slope of negative 1 is give us the angles where tangent and cotangent are both negative 1. And now see that all you have left are 2 lines with positive slope and 2 lines with negative slope. These are the angles where both tangent and cotangent are positive. The steeper one is where tangent is root 3. It has a steeper slope. The less steep positive slope is where tangent is 1 divided by root 3. These are both positive slopes. However, cotangent reciprocates that. So where you have a slope of 1 over root 3, that's where cotangent is root 3 over 1. Where you have the steeper slope of root 3, cotangent is 1 divided by root 3. And then we've got the same thing on the negative slopes. Here I have a steeper negative slope. The tangent for those angles is negative root 3. But the cotangent is the reciprocal negative 1 divided by root 3. The pair of negative angles that fall under a less steep slope than the slope of 1. The tangents are negative 1 over root 3. The cotangents are the reciprocals, root 3, negative root 3. With all of that, if you keep running that through your head over and over again, this is, and I'm going to keep saying this, we still have a lot of trig to go. If you can get some of these initial ideas solid in your head, it's going to make everything go much more easily. And this is fourth quarter. You're going to, as time goes on, you're going to want to not have to put in as much. You're going to be tired. If you put the effort in now, before you really get kind of like June is so close. If you put the energy in now, it's going to make everything be much easier to understand. So I just really want to emphasize how important that is. Now, we have 2 examples down here, and I have 10 minutes left. So for this one, I want to emphasize that we have root 3 over 3. That number, is that bigger than 1 or smaller than 1? This is the same number as 1 divided by root 3. So this is a slope that is less than 1. That means I'm dealing with a positive slope that is less steep than a 1 slope. That gives me the angles of 30 degrees. If I can get it to type. I am having some minor problems. There we go. It won't type on there. So 30 degrees, and then 180 plus 30 degrees, 210 degrees. Those are the 2 angles for which tangent is equal to root 3 over 3. Where is cotangent 0? Cotangent is the reciprocal of tangent. Cotangent is 0, where tangent is undefined. And that is your 90-degree angle and your 270-degree angle. Now, what I have for the rest of the examples are you focusing on sine and cosecant with horizontal lines, focusing on cosine and secant with vertical lines, and focusing on tangent and cotangent with lines that go through the origin. So right now you are going to come up with a lot of answers quickly. I'm going to try to zoom out a little bit because my touchscreen decided it doesn't want to work anymore. All right, here we go. Sine. Sine represents y. Negative root 3 over 2 is the third one down. That takes me to what 2 angles? $270 plus 30 is 300. 270 minus 30 is 240. And you do have the answers written down on the other document. I'm just going to say them out loud because it's going to take too long to write with a mouse. Yay. Okay, then sine theta is equal to 1. I'm looking for drawing a horizontal line where y is equal to 1, and that would just skim the top of the unit circle. This is a rare moment where there is only one answer throughout all the angles from 0 to 360. There's actually only one angle. But if you look at sine, solving sine equations as drawing horizontal lines at those y values, you can more readily see how you get only one solution when sine is equal to 1, whereas you get two solutions when it actually goes inside the circle. When your horizontal lines go inside the circle, you get two solutions. So this is 90 degrees only. When I'm looking at negative 1.5, negative 1 is this value. Negative 1.5 is lower down. It does not cross the unit circle. If you draw a horizontal line and you aren't able to cross the unit circle, you have no solution. I'm just going to put none because that's easier to write. No solution. When you run into cosecant, first reciprocal. 2 is 2 over 1. That makes the reciprocal 1 over 2. Cosecant's reciprocal is sine. And now you're back to solving an equation for sine. So realize that if you have cosecant or secant or cotangent, you can reciprocate them and just solve them by only going through sine, cosine, or tangent. And that saves half of your time. Sine is equal to 1/2 when I am at the first position above 0, and that takes me to my 30-degree angle and my 150-degree angle. Next, I have cosine, but due to time, I'm going to head over to tangent and try to work through this one a little bit faster. Tangent is equal to 0 when I have a 0 slope. That gives me the angles 0 and 180 degrees. And that's part A. For letter A. For letter B, tangent being equal to 1 means I'm going to draw a line with a slope of 1 that goes through the origin. That's going to be my 45-degree angle. And this angle, that is 180 plus 45 degrees, 225 degrees. Tangent is equal to √3. That's a positive number, so I'm dealing with a positive slope. For my positive slopes, I have a slope of 1, a steeper than 1, and a less steep than 1. √3 is steeper than 1. That takes me to the angle 60 degrees, and this angle over here. And that's actually just if you take 60 and add 180, that will give you this angle. So 60 plus 180 is 240. Now, I will tell you that when I run into cotangent, I prefer to just right away reciprocate it. Reciprocal of cotangent is tangent. And negative root 3 is the same thing as negative root 3 over 1. The reciprocal of negative root 3 over 1 is negative 1 over root 3. So I can actually just immediately change it over to tangent and then remember less. When tangent has a negative slope, that means I'm dealing with one of these three lines. This one is my slope of negative 1. Negative 1 divided by root 3. 1 over root 3 means less steep, and that would be this slope that takes me through the angles of 30 degrees before 150, or sorry, before 180, which is 150, and 30 degrees before I hit 360, which would be 330 degrees. And you can always do that when you go to cotangent, is just reciprocate it, and then you have it. I believe time is up. I'm going to keep recording the video and finish this, but it is lunchtime. So you are free to go. I'm going to work with this one, though, on the video. So if cosine is negative root 2 over 2, you too, thanks. It's okay. If cosine is negative, then I'm drawing a vertical line, and I am dealing with 3 vertical lines. Here's 0, and I go negative 1 over 2, negative root 2 over 2. That's what I'm looking for. So this is where cosine is negative root 2 over 2. This angle is 45 degrees beyond 90, or you could say 45 degrees before 180. And so that's 135 degrees. And then 45 degrees beyond 180, 207 or 225 degrees. So those are your answers to A. For letter B, draw vertical lines for cosine. Where cosine is negative 1, that's when I'm all the way over here. That's where x is negative 1. If I draw a vertical line for x equals negative 1 to help me find when cosine theta equals negative 1, I only hit the circle in one spot. Again, this is a rare time. Usually when I draw a vertical line, it either is going to cut the circle and run into it 2 places or run into it nowhere. This is running into it only at 1 point, and that's 180 degrees. And that's the only answer between 0 and 360. Now this one's a good one. If cosine is equal to positive 3, a vertical line at positive 3, well, here's a vertical line at positive 1. Positive 3 is way out over here. So I've got 1 unit, 2 units, 3 units away, vertical line, way out here. It does not cross the circle. If I draw the line x equals positive 3, it will not cross the circle. I have no solution. And finally, secant. I find it easiest to look at what is the reciprocal. Secant's reciprocal is cosine. The square root of 2 reciprocal is 1 over root 2. Now, my special numbers for cosine are 1 divided by 2 root 2 divided by 2, root 3 divided by 2. So which of those is this one? If I multiplied the top and the bottom by root 2, that's supposed to be a multiplication sign, but by mouse, I get the square root of 2 divided by 2. So the square root of 2 divided by 2 as a vertical line takes me to the angles 45 degrees, and then this angle, which is 335 degrees. And that would then just be the answer, and I wouldn't have to go back to secant. Once I reciprocate, I don't need to use secant any longer, just cosine. So that wraps it up, and enjoy your homework tonight.